Well, hello everyone, and welcome back to my channel, or welcome to the channel if you've just tuned in. This is an ongoing part of a Breville radio restoration. Now, there's a couple of videos before this one, and this one is all about checking some resistors, and checking to see what is ahead of me with this. Now, Breville, it's an M97. Well, that's the one we're going with. There's a few people who have thought differently of this, but this circuit is identical to the one that we have here. Now, to start with, a resistor is in here, 40 ohm on the grid of the AK2. Now, one end goes to the grid, the other end goes to your tuning cap. And then we've got this funny switch arrangement here. This is the horrible looking concern we've got. I'm not real keen on that resistor. That doesn't look very promising at all there. But it goes to the tuning cap, comes up here to a tag strip. This fella goes to your grid, your top cap. And we've got this strange little arrangement here being cut on an angle. It is on an angle, which is rather odd. So if someone can shed some light on this, this sort of looks like there should be something, well, between there and there, or I don't know. I really don't know. Yes, I can see what it does on the diagram, but here is a totally different ballgame. So what we're going to do for a start, this resistor is 40 ohm and obviously not real good. It's a wire wound. Bit erratic on the tuning circuit, but yes, I guess with static or lightning or whatever, this could protect things, I see. Now, going to remove the resistor from here and check him out. We know he's crook, but there is wire underneath. There's wire in there. So, yeah, I don't know. We'll check this fella out. And also, with the radio, I'll show you what we've got to check out there. And this is the chassis. You may remember we've checked the transformer. We've actually checked that we've got HT. The 80 is working. We've put in a couple of electrodes on the previous video. So now let's take it a step further. As I said, this is a long-term project, but I'll record everything I do with this old girl until we get it perfect, in perfect working order. And I think we can. Okay, this resistor here is a 15K resistor with various taps. I have to remove this and check. It's been very dark down here, very black. We've actually measured it, and there's areas not measuring. So we've got to pull him out. We will also go through one by one and check each resistor in these. There's a wire wound there. There is also a very sus looking wire wound up the end up here. Now, where that is in the circuit, I'm not sure. We'll get there when we get there. So for the meanwhile, this fella here is the concern. Is it resurrectable? Can we work out where the taps were for the voltages, so forth? So, yeah, we'll attack this one pretty well first and see what we can find with him. Okay, so we'll remove the other resistor off the tuning cap and then work on this. Okay, we'll get this fella off. Now, if some of you guys have done one of these sets, I won't know much more until I get this off, but can you advise me in the comments, what this contraption is. It looks like it may have been some sort of switch, which, according to the diagram, was a switch. Okay, but this is not a switch. I have to put this fella through the sandblaster and clean him all up. He's running nicely, but we need to clean him up a bit. So we'll get this resistor off and have a closer look at him. Right. And when we're cleaning him up, we'll also do these fingers that are the earth of your shaft. Make sure you make good contact on your shaft on the tuning gang to ground. Both these are grounded. Okay, so this fella, I'm going to take him off this piece. This is a very strange arrangement, but I think this may have been a switch at one stage and appears to be broken. I'd love your comments on this or some other photos. I can't find anything else on this radio. The M81, which is very similar, doesn't have this arrangement at all. It's only the M97 that has the switch on the tuning gang on the front end, and obviously for local and distant. Okay, so we'll get this all off, clean him up. Okay, well, here we are. This wire I have unwound off the outside of this resistor, and strangely enough, it looks like it's been put on there separately. This piece is unwound, which is that length. Okay, now I'm going to see whether this resistor is still okay, because this winding in here looks, well, it looks normal, looks good. So let's check if I can get, and no, it's not. We'll just check up here further. No. Okay, so the resistor is open circuit. So I'd say someone has put this piece of wire in, which is obviously a piece of nichrome wire, to repair this problem with this resistor. Okay, let's check. If I put it on there, it'll work better, won't it? Because what I want to do, check this wire. Can we get any sort of reading? Okay, yes, we can. We've got 8-9 ohms roughly. Let's see, can we get a good reading there? Okay, we've got about 13 ohms. Now, this is supposed to be a 40 ohm resistor. I don't know what the original is. I don't know where this is broken. It may be broken just in there. Yeah, that's probably where it is. Is this wire part of the original piece that's broken off or what. I'm going to have to put this under the microscope and have a bit of a look at what this is. Now, saying this, I've just discovered something. When we first checked this radio, we thought, hang on, there's 5 valve caps here. We only used 4. Oh, well, there might have been 4 and we only used 3, whatever it was. I thought, well, this obviously goes to the AK2, but I don't think this goes to the AK2 at all. I think there's been a little bit of rewiring done here. If I get the sheet. Now, you guys are probably going to be with me here. You may know more than me about this. But this switch here, and here, this is our band change. This is our band change switch. And here is switching our antenna coils. Okay? So this is actual fact, comes down to 40 ohm, comes off the grid of the AK2, so it may have been, to the tuning capacitor. This also has to come in here, and this is where this extra wire seems to be elusively appearing when I first tested this radio. This wire, I'm thinking, goes to the antenna coil. Well, it does, but the antenna coil is mounted on the radio. So something goes from that point there, between the 40 ohm and the tuning cap, to the band switch. So we've got to find where that goes, where that is, and hence there is the extra wire that we had in the first place. And there's a tuning, a little trimmer there that trims the whole lot of this. Now, when I don't know which is which. I don't know whether up is medium wave and down is short wave. I don't know. But we've got to work this system out just in here. I'll trace where the aerial comes in and go to here, and where these positions are on the antenna coil or the band switch, where these switches are, where the wires are on the band change switch. Okay, so for the moment, our next mystery, we're just going to leave this for a while. We've checked this resistor. We'll see what we can do with him. Definitely a 40 ohm. Okay, the next resistor that we're checking is this fella here. Now, this is our various HT supplies. One goes up to your control grid here. The other one comes across and goes up to the plate of the grid of the AK2. So this resistor, the points of 1, 2, 3, and 4, the other end of it. So we've more or less got 1 and 4 as the resistor, 15K, and there's 2 taps on that resistor. Now, this radio is a long way before my time, so I'm, struggling a bit with this one as to working it out. Okay, so I'll show you something else. We'll bring the radio over here and give us a look here. Okay, there's the resistor in question. Okay, 1 wire, 2, 3, 4. Yes, it's definitely in there. 4 and 5. 5 connections. 1, 2, 3, 4, 5. There's 4 on the diagram. No other diagram is the same as this radio. All the other, well, there's a couple of others that do have this resistor, an M81, and it does, that do have this resistor, and it has 4 connections. So I'm a little bit dazed as to, no, hang on. No, I'm not. I'm being silly. Look here. There's no connection on this one. There has been solder there, but there's no connection. So we've got 1, 2, 3, and 4. I'm sorry about that. Yeah, there is only 4. Yeah, that's me ratting on about, things that don't exist. This is going to be a fair project, guys. There's a bit of work to do on this one. All right, so now that I've solved that, our next call will be to mark these wires, get the resistor out on the bench as well as the other resistor. We'll find out what we're going to do with these, and then after we've done that, we'll check the other resistors along the strip here. Okay. Okay, we'll clean this resistor up a little bit. Got some methylated spirits and just get him cleaned up so I can see what's happening. I know I could probably whip this fella out and put in a 33 or a 47 ohm. Not a problem, but that's not the original, is it? And we want this radio to be original. Right. A little bit of green stuff coming off there, a little bit of green paint. It's okay. We might dress him up with a bit of green nail polish when we've finished all this. That'll make him look nice. Okay. I'll put him under the Maggie lamp and see what I can find. That has taken quite a bit of paint off, but we need to do that to see, is this broken? Is there another end to this, or what's going on here? Rightio, guys, as I suspected, on top, right on top, that wire was just pushed down, and I'd say something's hit this and broken the wire. So this fellow, I'm pretty sure he goes from there up to this end, and this is the other end that's been damaged. So let's try from there up to the end of him. Okay, put him on there. Let's see, have we got anything here? Yes, we have. Yes, we have. 20 ohms. And what do we have on the other? So we had about 15 ohms, something like that. So what we've got to do is rewind this fellow. I'll have to, we've got to join this. We will lose probably a very small amount of resistance, but we will have to join these fellas. I'm sure we can solder them, and put a little bit of maybe super glue across the top there to keep everything intact while we're doing this. Okay, this is going to be delicate, so bear with me. Well, guys, I'm sorry to say I'm going to have to admit defeat on this one. It is impossible to wind this thing on with the gear that I've got anyway to wind it back on. Now, I'm just wondering, we got this fella, 39 ohm, that's a 40. Yes, it's carbon. It's an old style carbon that I can find. I don't know. Perhaps in the comments, you guys can guide me a bit on this. Does that have to be wire wound? Is it an inductance thing in conjunction with these coils? We can soon spear a resistor there, but is this varying by putting a carbon resistor there? Is it varying the inductance of a wire wound 40 ohm? So you might be able to help me out there. We've got one on standby here anyway, the carbon. But yeah, if it's got to be wire wound, well, we'll get a 39 ohm wire wound and put in there. It's just that I don't have one at the moment. So love your comments on that. How is that affecting the circuit? I'm no engineer. I have done years of repair. Certainly nothing, probably nothing as old as this one actually. So yeah, if you can help me out with this, we'll obviously go for a 39. But yeah, just let's have a chat about it. And I'm sure other techos out there would be very interested to know this circuit and how that resistor affects things. Why it was a wire wound at least 5 watt, I'd say 5 to 7 watt. Why did they use that? Why didn't they use a smaller resistor? So obviously the wire wound has got something to do with this in that circuit. Okay, really appreciate your comments. Okay, let's move on to the problem in the radio now. We've got this problem on hold, so we'll see what the next thing is going to be. Okay, I've labelled these. What goes on the bottom one? We missed the next one. Then it's number 1 as far as our tap is concerned, number 2 tap, and top. So we'll unsolder these and hopefully not get mixed up with anything down the track, but well, this resistor has to come out. So I wonder what this old solder is going to be like. Okay. That's not too bad. Bend these down. Now, I was just checking then to see if my microphone was on. So many times I start recording, as I'm sure you guys do, and forget to put the mic on. Well, I suppose we can always do a voiceover dub, so just not quite the same as live. Come on. Okay, that's the next one. I just might tack those together so we know they go together. And they probably won't stick now. Oh, that's right. And then the next one. Okay, he's off, and going through the top here, and the top one. If we can find out what the taps were with this, we'll probably replace this with, if we can't fix it, of course, with a high current wire round. There's not much else we can do at this point. Right. Okay. We do have an earth point up the top there as well. Now, it's a matter of getting some cables out of the road and getting this resistor out. I think I can get it this one. And a little bit of WD-40 on them, I think would help. Now, we'll try and get this fella out. Excuse my hand there, I don't quite know where to put it so you guys can see what's going on. I don't believe it. This one is actually loose. Just need a bit smaller screwdriver. Okay. And not sure. Won't fit in. We're going to have to inspect a little bit further on this one. Okay, this fella here, he doesn't want to play ball for me. He's had a very hard time, that one. And gee whiz, so is this one. These are going to be very difficult to get out, I think. So let's get a socket and see if we can get a socket on him. Next size up. And it's him. And he's coming off. So is my socket. Right, get the socket out of there. And we'll be certainly putting, well, I was lucky, we'll be certainly putting a new screw in that one. He's not real good. Okay, we have a washer. Okay, now it's this fella down the bottom. He's going to be a little bit difficult. Gee, how are we going to do this? Oh dear, why would they put him behind this? Directly behind the tag strip. Let's see. Oh, he's cracked, and I think he's going to move. Oh, I don't believe it. Okay, give me a finger. And there. And it's unscrewing. Amazing. Because that is really, really rusted up. There's the screw, and I don't know how that come undone. Okay, let's get this resistor out. Right, here we go. And I see broken wires. Anyway, this, yeah, this is something else. And as you can see in there, this old girl's been pretty warm. Very warm indeed. Gee, guys, we've got our work cut out with this one. This is going to be a long video. Not a long video, long, lots and lots of episodes of this. Okay, we've got him out. We can manage all that later. I think we've got more problems than meets the eye here. Let's have a closer look at this. Have wires, okay. We do have some loose wire here. You probably can't see any of this though. Yeah. So I've got to work out what's happening here, but this thing has been hit from underneath, and you can probably see there, if I can focus okay, there's a fair bit of wire damage in around here. So I don't quite know how we're going to attack this. I'll measure from here to here first. Hopefully we're making contact here. Then I'll try and get something from here to here. This one is not used, but the trick is going to then be the area where this has been very hot, this one here. And obviously excess current draw, probably caps, a valve conducting too hard, probably the coupling cap on the audio. So yeah, it's made a bit of a mess of this fella. So let's see if we can start by doing these two. This is a little bit worse than what I thought, actually. I better give yourself a little bit better look here. There we go. got a just a blue foam mat to sit things on here at the moment. Okay, from here to here, 2.9k, so 3k. So we better write this down. Is this the top? No, that's the top. So this is the bottom, working our way up from the bottom. Yeah, our first one is, we'll call that 3k. So maybe a 3.3k will suffice for 1 to 2. No, hang on. This one's not used, is it? Yeah, it's this one. Okay, can we get a reading here? Yes. I don't think 168k is the reading we want. Let's tip him upside down because we've got a 15k resistor here. Okay, what do we got there? 4k, 4.4, 5, and what do we got here? Right on the edge, 5.3. So maybe 5.6k would. Yeah, I think we can do a from our starting point here right to the edge, 5.2, and then we've got 6. So I don't know what's not making. This fella obviously isn't making good contact, although I think we got contact there. 6k. Yes. There we go. 6.1. So 6.2k. We'll write this down to start with. Okay, so that's what we got so far. So we're not going on to this one, but from here to here we've got roughly 6.2k. Now we've got to either come in from the top down to this one or up from here, and there are breaks, but we can still work this out. This is a 15k resistor, so yeah, it's 15k minus 6.2 that we've got here, so we know what this one is. But what is this fella here? So from the top down, say, to this one is I reckon 1.8. It moves a little bit, move him around a little bit. But where he wants to sit, 1.6. I'm going to call that 1.8 from the top to there. It's 1.6. But if you move it a little bit, 1.5, yeah, 1.6. We're gonna. I suppose we could go 1.5. Yeah, I'm going to call that 1.5. So we're doing 1.5k from the top there, which is from there to there, and this one is from there to there. So there's our values. This is what we've got. So if we go from here, all we've got to do is put in a 1.5k, the 6.2, and we do the maths on what this one is. I haven't got a calculator with me. I'm too old to think about all this. And we'll work that out. And there's our resistors. Now, probably put in 10 watt resistors, I think. I don't know what this has been, but it's very, very fine wire. And I don't think that would be any more than 10 watts. Of course, on the circuit, it says nothing. There's no indication of what it is or anything other than this is 15k. Righto, we'll remove some of these bands and probably take the tabs off and just see. We might put an insulated bar across this to mount the other resistors on, and reuse some lugs, reuse these lugs on the ends. We'll see what we can do. And now that I've removed one of the contact bands, we can also see fairly clearly it's 15,000 ohm. So we've got that. That's on the circuit. I'm pretty sure. Let's grab the circuit. I'm pretty sure. No, this isn't mentioned on the circuit. But somewhere I have seen the value of that resistor. Just a moment, I'll have a look on another diagram. Okay, model 81, not 97. Is our resistor, 15,000 ohm. Okay, so more or less the same sort of circuit, more or less, but it is different. It is different. So there's our resistor anyway. A little bit different to the other one, but it is definitely a 15,000 ohm. So we're spot on with the value. Okay, so the next thing I will think about will be how to rebuild the substitute of this fella and have a look up there, and we go through these fellas, and that one in the end there is very sus. I've got to find him on the circuit. This fellow up here, he's also been hot and is also wire wound. So yeah, there's a few wire wounds in here. Once we get the resistors worked out, the caps are no problem. But yeah, we'll end this video then as this part of the next. Yeah, we'll end this video then as for the conclusion of the resistors and what they are and how we're going to rebuild this thing. Well, guys, there's the patch where she come out. This big power resistor. Now, I've tried cleaning up down here, and it's actually going to clean up, no problems. This is not the main issue. The main issue is what's left of the resistor. Yeah, I've unwound it. It was, yeah, it was shot. It had been hit, as you probably saw in the video. And yeah, I can't rewind these things. So what I've got, or what we've got to do is that. Okay, so that's what we need to make up. Now, what I've got a 10K, I've got a 15. Oh, one in stock. So I've got two of these. They're both, well, almost look like new old stock, but they're being used, but gee, they're in good condition. So I don't know whether to I'm really going to need two of these together to get the extra. What do I need? The extra 6K. Yeah, I didn't want to do that. I sort of wanted a couple of taps on this and then maybe an extra 10-watt resistor on the end. These are 50 watts. Probably, I don't know. They're the same size as this fella. The wire looks roughly the same. So this could have been a 50 watt. I don't know what it is. So this is the dilemma I've got to work out. So on the 10K, we can we can go a 1.5 and the 7.3, and that will give us that part. So that's 8.8, and then 8.8, and then we need another 6.2K. So 8.8, 9, that's 1.2 off that. So we need about another 5K. I'll see what I can manage with this. Yeah, you guys might have a lot more suggestions on this too, as to what I can do, or if anyone knows of a 15K 50 watter, or even a 30 watter, something like that. But it does have to be adjustable with the bands. Okay, so we'll move on from that and just check the rest of the resistors in the circuit and measure them up, see what else we're going to need. But this fellow in here, he's the main concern at the moment. I'll also start to do a little bit of cleaning up, but not a terrible lot, because I want to find out what else is wrong with this radio first. Okay, we might give us a bit better view of the other fellas, and we'll measure them up and find them on the circuit. Okay, we'll start from this fella here. He's a little wire wound one. Now, we'll chase him on the circuit in a moment. He does have 400 written on him. So, can you guys see the multimeter? Yeah, that'll do. See enough anyway. So we're looking for 400 ohm. Oh, come on, Baz. On there. And we've got 406. That bloke's in pretty good order. Okay. What I want to move on to is, this is, what's this fella? This fella's 15 ohm. He's also a wire wound. So, let's check him. And he's 160. Is it? No, sorry. 150. So it's 150 ohm. So there he is at 160. He's within limits, so he's okay. So that's good. That's the second one I've tested. Now, moving along to the next fella, which is this fella here. This fella looks a bit sus, but you never know. Okay, there to there. Now, what have we got? 590. Now, the wire is actually loose on this fella, but I'm not. I'll just take him around there, around that way. Something written there, but I don't know what it is. But it's 590 ohm. So we could probably assume it's 600 ohm. It Where is he on the circuit? Gee whiz. We do have a 500 here, but that's on the 42. This isn't on the 42. This is actually on a 6D6. 6D6, 400 ohm. So that will be that resistor. And he does have a 0.1 across him there. No, that's not across. Yes, it is. He's bridged there, and it's a 0.1 to ground. And that 6D6, that's him there, 0.1 to ground, and the 400 ohm. So, yeah, he measures okay. Even though he looks a bit sus, he's not. He is, well, he's 590 ohm. Yeah, let's see again. 590, supposed to be 400. Should I check it or not? Now we go back to the circuit again on an M97, which I'm using, because this arrangement here is the same of our multi-tap resistor. But if we look at the 6D6, this arrangement here is different. We've got the 1000 ohm going to ground and a 0.1. What is this? Yeah, the 0.1 isn't going to, or is this a ground point? I'm not sure, but that's 1000 ohm on the 6D6. Now, if we swing back to an 81, and model 81, as you can see, it's 6D6, 400 ohm and a 0.1 to ground. Yeah, this is sort of the correct circuit, but this goes in different places. But anyway, we'll chase this a little bit further. Okay, so he's 590, supposed to be a 400, a little bit high. I will probably change this fellow to a 390 ohm wire wound, or maybe 470 ohm. Anyway, we'll come back to him. Now, we're just checking for the moment. Now up here, if I can get our light in the right place, we've got another little wire wound, and this is 1000 written on this. So is this in a different spot? Just a moment. It wouldn't matter which spot it is. Nothing makes any sense here. So it's got, is it 1000 or 100? Let's measure it. A little bit tricky here with without the exact circuit. 250. 250. I didn't think that was 250 written there. Let me get some light here. What do you guys reckon? That looks like 100 to me. Now, this is, where is this fella? This fella goes down to ground. Yeah, that's ground. This one goes up to pin 4 of our, what is he, AK2, pin 4. Now we go to, which is our cathode of our AK2. This is him here. It says 250. We have 100. Okay, we'll swap to a model 81 to our AK1, for instance. It's also 250. But we have, it is definitely 100 written on that. And as far as resistance, 250. I think there must be something else written on the other side of this fella here. It may be one, but meaning something else. I don't know. I might lift this fella, but that's reading 250, which is correct for the cathode resistor of the AK2, the 1K2. What is it? AK2. Yes. There's a lot of activity going on here at the moment, and I'm distracted. Okay. So that may be right. Obviously, capacitor's got to be changed. Down in the we'll come back to the caps. I'm not going to start on them at the moment. We're going to keep going with the resistors. Now, let's see what else we've got here. Can I give you? I need a multimeter like Mr. Carlson's, with a remote head on it. Gee, that'd be a handy piece of gear, that would. Okay. Body end and dot. So we've got body 5, 0, and 4 zeros. So 500K. Let's see. And he's 870K. Pretty high. I don't really want to change these dog bones either. I sort of wanted them left original, but that fella's a bit high. This fella, well, he's 50K. He's got an orange dot. 79. Yeah. A little bit high. Okay, well, we'll try this one. And it's the same, 50K. 83. These are not looking good, are they? But maybe because they're in circuit, we will lift them out. Body is 2, 5, 4 zeros, 250K. 418. Well, what do you guys reckon? I reckon we're going to have to change some resistors here. There's a little one in here which has got a lot of corrosion on one end of it. Don't actually know what it is. It looks like a 1 meg. Can you guys see the meter? I'm trying to keep my hands out of the road. Where is he? It's the next one over. I think he's a 1 meg. Let's see what he measures. I don't think he's going. Oh, he might measure something. Fucking 8, 9. One meg. That's he's pretty close, and he's probably the worst looking resistor of the lot. Okay, we've got another. Bring this over. We've got another 1 meg in here. Let's see what he measures. 1.1. So he's okay. Right. We've got another little dog bone just up in here. Now, he's a 50k. I'm not real sure what he connects to in here. Where is he? He's there. He's 78k. He's also way above spec. So, looking at all this, these dog bones, I will lift them, and we'll do a quick evaluation on this whole thing. But I think they're going to have to be changed. They're just too far out of spec. The wire wounds, well, this one here is probably correct. This one's probably correct, even though they don't exactly match the circuit, which is, yeah, really strange. Probably one of the circuits it does, but not a 91, not a 97, and not an 81. All right, we'll start here. Give you guys be with the meter, and this one here, we'll lift him. This fella. So 5040. So 500k. Okay. Now, and we're in circuit. We've got 560, which is not too bad. We'll try this one. 5030, 50k, 79. Let's lift him and see if he's still 79 when I lift him. And then we'll also find him on the circuit. Okay. I've lifted him off there, put our meter on him, and we have 78k. Now that is a 50k. So 78 is just way too high. Unfortunately, this little dog man's got to go to his maker, and we've got to get him out. So unfortunately, he can't stay. Now, where is he on the circuit? He goes to a what's this fella here? This is a bit hard to trace on these fellas. This fella is a 25 picofarad. So if we find a 25 5 picofarad on here somewhere. Okay, where are we looking? Unless it's this fella here. Now what is he? He is a 50k. That's a 50k. Goes up here. No, that's not him. Comes down here to another little cap. Oh, gee. Pause this video for a minute and we'll try and chase this down. $25 goes to ground. Okay, it's a 25 picofarad to ground. You've also got a 0.5. Don't know what that is. Righto, guys. I'm back. This fella here, this 50k, is in fact where we were looking. There's our 25 picofarad up here, and there is our 50k. There. That there's a little cap there. I'm not sure of the value of him. It doesn't say, but this is a 0.25 meg, so 250k, and then we've got a 50k going down here, which is actually on our it's a B plus line there on our 8 microfarad caps. So up here we're looking at this one here, 50k. It measures 78. It's too high, so he's getting replaced, that fella there. Okay, so this one before it, this one is a 500k, so it's a 0.5 if it's got there, but yeah, that one there is actually okay. He's a 500k and or a 0.5 meg as it's written here, and he's fine. So that fella's fine. This fella's got to be replaced. Okay, so we'll gradually keep going through this. I'll get to this one where we'll replace this, or we'll mark down what's got to be replaced here. And then we'll do the lot once I lift this ladder, this terminal ladder out. So, okay, we'll be back. Right, guys, I have replaced the dog bone that was here, here, and here. They are all reading high, so I'm going to go through and replace that fella. Probably replace the two 1 meg resistors. There's a little one in there and one here. I want this radio very reliable, and a good restore. So the next one we're going to take out is a 250K. We'll just see what he measures. And so far they've all been high. So just get in here and look at that, 417. So yeah, let's get him out and just do a reading with out of circuit and see what he reads. Okay, got him lifted. Let's see what he reads. 419. There you go. So we go body, end, and dot. Okay, so it's 2. The end is 5, being green, and the dot is another 4 zeros. So 2, 5, 4 zeros. 250K. And yeah, that's 419. And let's see where he is on the circuit. Okay. Now I'm looking at the M97 circuit at the moment. And where are we? There he is there, the 0.25 meg, 250K. So that's the one we're replacing now. Very high. We've done this fella. We've done this one. We've done this one. We're doing this one now. Right, and seeing this fella is 250K, I'm putting in a 270, so it's going to be 20K high. If I go below this, it'd be a 220, which is 30 below this fella. I'd rather do 20 above. So we're using a 270 ohm, 1 watt. Okay, so we've got him done. This fella next. Don't know what he measures, but we're changing him. So let's get a new one in there. Okay, we'll see what this fella's sitting at. 1.1. So both those 1 meg resistors are actually quite good. Once again, body and dot, guys. Brown, black, and 5 zeros. Brown, 1, 0, and 5 zeros is 6 zeros, 1 million ohms, or 1 meg. Okay. And these are called bed transistors. Transistors, Baz. These are called BED resistors, bed resistors, body and dot. Okay. All right. Get a new one in. Right. Now, I haven't shown you guys me soldering these in. Simple reason, most of the time my head or my arm or hand are in the road. But anyway, we'll just show you what I'm doing here to get these fellas put in. And any that's not quite soldered properly, because some have got 2 connections on them, we'll come back later and do that anyway. Okay, now another thing with my resistors, I put them all the same way around. Absolutely no reason. Resistors aren't polarity sensitive or anything like that. They're just resistors. But if you look, we've got the gold band up the top of all of them. Strictly just appearance, just to make them uniform, so that, well, it looks like we know what we're doing here. Okay, so yeah, if you're doing them, it just it's just a nice way. Once it's finished, someone else looks at it and thinks, geez, you know, that's not a bad job. I've got to resolder that one too. He didn't come up real well. Got to lay him flat. Okay, let's get on to this one. Righto, guys. One for you guys this time. This fella. What value is he? Body, end, dot. You got him? 5, 0, 3 zeros. 50K. Okay, so 5, no zeros, 3 zeros. 5, 0, and 3 zeros. 50,000 ohms or 50K. Okay, let's get him out. Seeing this is the last one, I might leave the camera on and you can have a look at what I'm doing here. There's a capacitor in here that has got nasty looking leads on him, but we'll do him separately when we're doing the caps. At the moment, resistors, and then we'll mark them off. We'll do a Manuel type mark off with our PDF diagram. I'll show you what I'm doing pretty soon. There we go. Okay, off there, and he comes down here onto a trimmer cap. Be interesting to see what value this one is as well. Now this trimmer cap certainly needs taking out and inspecting, but as I said, for the moment, just get the resistors done. This is a big restoration, this one. It's big, but it's enjoyable. Okay, now let's see what he measures, shall we? 50K. Is he in spec? You guys see there? Yep. Okay, 50K, and we're looking at 77, almost 78K, 77.8, 78. So 78K. from 50k. So yeah, all these fellas, all high. Okay, let's put a new one in. That's him done. Him done. That one, that one, that one, and that one. Okay, now I can't see any more resistors in this machine, but we'll tick them all off on the schematic. This this trimmer here, a little bit of rust on the mounting bolts, and actually rust there, so we might have a bit of mica disease or something like that in him. We'll definitely take him out and clean him, check him. If he can be left in there, would be really good. So the wire wounds are all okay. We're leaving them as is. So after that, capacitors. But probably in the meantime, I might start doing a little bit of cleaning up under here. The power transformer I will remove. We want to clean up the area there and probably repaint the transformer. But doing the top of the radio, I'd like to remove the transformer anyway with a repaint. So I'll have to jot down where everything goes here. The 6.3 volt windings, which seeing there's 2, 3, 6.3s, there may be some that are that are actually ground. Maybe there's not, but these are going to have to be. Oh, sorry, these are going to have to be replaced somehow. So they've actually got to be isolated. We'll have to get a little bit of rubber tube or something like this to fix these up. But it looks like the 6.3 is isolated totally from the chassis. But all that's got to be double checked before we take these fellas off. The one up here, I think, is a 2 volt filament winding, 240 in on this fella. And this might be that's your 80, so it's a 6.3 as well. All right. Now I'm going to leave this video as part 3 or 4. What are we up to? 3, I think. Going to leave it, and this is just the resistor job. So I'll clean him up, remove. We'll get the power transformer ready to remove, and we'll put that in the next video. Caps and the cleanup. So lots and lots of work to do yet. If you like what I'm doing, give us a thumbs up, subscribe. If you don't like what I'm doing, mention it in the comments. Would you like to see me fix other things? Do you want to see more modern gear, more vintage gear? Anything? Just mention it in the comments. Okay. So Anyway, please remember to subscribe and hit the bell. That way you'll be notified when I put the next video up. Okay, guys, until next time, it's bye for now.